If you've invested a lot in your turntable, tone arm, and cartridge, you definitely want to make the most out of it. In these tutorials, I'm going to show you how to make your turntable sound awesome. In today's video, I'm going to show you how to use the Analogmagik software to fine-tune every setup parameter. The software comes with two test LPs. One is a 33 RPM and the other one is a 45. It also comes with a USB license key which you need to plug into your computer every time you use it. Having a correct turntable speed is essential for accurate vinyl playback. If the speed is too fast, the pitch will be too high, or the opposite would be true if the speed was too slow. The most popular tool for setting up the turntable speed is to use a strobe disc. A strobe disc has two disadvantages: accuracy based upon visual observations, and when the cantilever is landed on the record, the dragging force of the stylus, although very small, will slow the platter down ever so slightly. So, a strobe disc will never totally be accurate. The most accurate method of calibrating turntable speed is to analyze a test tone while the platter is spinning. The Analogmagik software comes with a test tone for 33 RPM and 45 RPM. The test tone is recorded at exactly 3150 Hz. Therefore, simply adjust the speed until the software displays exactly 3150 Hz. Repeat the same process for the 45 RPM test LP and you will achieve the correct playback speed. Now, let's talk about wow and flutter. Every turntable will experience some sort of speed variations, which can be caused by a lot of things. For example, a turntable's belt which is too loose or too tight, or an idler wheel or rim drive which is exerting too little or too much tension on the platter. To achieve the most accurate vinyl playback, it is desirable to have as little wow and flutter as possible. The Audio Engineering Society standard of measuring wow and flutter requires sampling a test tone of at least 30 seconds. Therefore, please be aware that this measurement will take longer to compute. Now we will look at how to make use of the wow and flutter function. Here is a good example. The pulley on this belt drive turntable is manufactured with a slight imperfection. It is slightly off-centered. Because of this, it is producing an oscillation, resulting in a bad wow and flutter measurement. It also produces a bad vibration measurement, which we will introduce in later tutorials. Here we have the VPI Titan turntable with their famous rim drive. Have you ever wondered how much pressure the rim drive should be exerting on the platter? Or have you wondered how close the motor should be to the platter? Now, with the wow and flutter measurement, you can optimize the rim drive tension or motor distance by choosing the one which yields the lowest possible wow and flutter. The same function is also very useful for determining the optimal distance for turntables with a separate motor. Have you ever wondered how far the motor should be placed away from the turntable? With Analogmagik software, you now have a scientific way to determine the optimal distance. Simply choose the distance which yields the lowest level of wow and flutter. Thank you for watching this tutorial. In the next video, we will talk about setting azimuth. Stay tuned and see you soon! Azimuth refers to the horizontal balance of the cartridge when viewed from the front. This in turn determines the angle at which the stylus sits on the record groove. The theoretical assumption is that when the cartridge is perfectly parallel with the record surface, the stylus will sit perfectly in the record grooves. A good starting position will be to align the head shell so that it is perfectly parallel with the record surface. A good tool for this job is the Acoustical System Smart Stylus acrylic block. This allows you to visually gauge the cartridge body versus the parallel lines printed on the transparent acrylic block. For a rough setup, most people will stop right here and think the job is done. If you want a precise setup, the job is far from over. And this is where Analogmagik comes in. All phono cartridges are made by hand, and therefore the stylus may not be actually perfectly perpendicular to the cantilever or the cartridge body. The actual stylus is very small, and it is literally impossible to visually determine how it is actually sitting on the record grooves. Assuming if your eyes are good and you are able to set azimuth visually, it is still based on a static setting. Once the record starts spinning, your azimuth will immediately be off. On this diagram, you will see exactly what we are trying to achieve with setting azimuth. On the left, you have the stylus sitting perfectly in the record grooves. When the azimuth is set incorrectly, such as in the middle and on the right diagram, notice how the stylus is tilted slightly to the left or the right. This will result in left channel signals leaking into the right, or vice versa. This leakage between channels is called crosstalk, and it is expressed as a negative decibel number. The Analogmagik software offers a scientific way of determining azimuth based on measuring crosstalk between the left and the right channel. Using the Analogmagik software azimuth function and the test LPs, take readings of the crosstalk for both the left and the right channel. If the left is greater than the right channel, twist the cartridge slightly by approximately 1 degree, and repeat the measurement or vice versa for the other direction. An optimal azimuth setting is achieved when the difference between the left and the right crosstalk numbers are as close together as possible. You may have to go back and forth a few times to find the right azimuth setting. All cartridges will have some inherent crosstalk between channels, but higher quality cartridges usually have a lower level of crosstalk. On high quality cartridges, you can achieve a crosstalk number of within 0.5 decibels between channels. It is important to note that azimuth is also affected by anti-skating. So if you are unable to achieve a satisfactory azimuth number, you may need to check anti-skating, which we will talk about in another tutorial. Thank you for watching this video. Make sure to watch the next one when we learn how to adjust the vertical tracking angle. Hi, my name is Lauren from Analogmagik. In the last video, we learned about azimuth. In today's video, we are going to learn about VTA. Vertical tracking angle refers to the angle of the tone arm when viewed from the side. This in turn determines the stylus raking angle, or the SRA. It is the angle in which the stylus is raking the record grooves at. The theoretical assumption is that the optimal SRA angle is the angle at which the LPs are cut. In most cases, this will be 92 degrees. If the VTA angle is set too high, the sound will be tipped up where the frequencies are exaggerated, and low frequencies will become recessed. If the VTA angle is set too low, the reverse will happen, where low frequencies become fat and woolly. A good starting point will be to start with a perfectly horizontal level, and gently raise the height of the pivot column, or the back of the tone arm, to approximately 15 degrees. There are many tools on the market which allow you to gauge the vertical tracking angle. The Acoustical System Smart Stylus is such a device. It is an acrylic block imprinted with grid lines which allows you to gauge the horizontal leveling of the tone arm. Some people will even buy USB microscopes to enlarge the stylus onto their computer screen in order to achieve the perfect 92-degree angle. Visual methods provide a good starting point for the VTA measurements, but it isn't without its shortcoming. First of all, there is no guarantee that you are eyeballing it at the correct angle. A slight tilt of your head or your eyes, and the target will be off by a few degrees. Secondly, there is no optimal way to determine the true center point of the stylus. It is a guesstimate at best. Thirdly, all visual methods rely on a static platter where the LP is not spinning. Assuming if you can visually set the stylus at 92 degrees, the angle will immediately change as soon as there is a dragging force created by the grooves of the LP as it rotates with the platter. So how do we measure the VTA? We have to understand how the 92-degree angle was derived in the first place. The theoretical 92-degree angle is a level which is assumed to produce the lowest number on a measurement, called the intermodulation distortion. So if the lowest intermodulation distortion is what we're after, why not simply measure this number? That is exactly what Analogmagik software will do for you. Using the Analogmagik test LPs, which are recorded with a test tone specifically designed to work with the special algorithms which we've incorporated into our software, Simply play the VTA test tone and the software will compute the intermodulation distortion percentage for both the left and the right channel. As you change the VTA and repeat the test track, you will find a correlation between the IMD percentage number and the corresponding VTA angle. The optimal VTA angle can be found when the screen shows the lowest intermodulation distortion. We believe that this is the most accurate method of determining VTA because it is based upon actual live measurements while the LP is spinning. The results will not be affected by any errors based upon visual methods. It is important to note that the VTA measurement is highly sensitive to vibrations. You may need to minimize the vibrations experienced by the turntable before you engage in this measurement. Make sure to watch the tutorial where we talk about minimizing vibrations. Thank you for watching this video. Make sure to watch the next video where we talk about anti-skating. There are no shortages of bizarre methods of setting up anti-skating. Some people have suggested letting the cartridge skid across the blank record groove and eyeballing the speed of its movements. Others have used a mirror to cut the shape of the LP, and anti-skating is determined by watching the cartridge slide across the surface. In our opinion, none of the above methods have a direct correlation with what we're actually trying to achieve with anti-skating. Let's take a step back and see what we're trying to achieve. When there is too little anti-skating force, this force will cause the stylus to apply too much pressure on the left or inner groove walls, causing a higher level of distortion on the right channel. When there is too much anti-skating force, it will cause too much pressure to be applied on the right or outer groove walls, causing a higher level of distortion on the left channel. Please note that the force is not linear across the entire LP surface. Therefore, the optimal anti-skating force is only optimal at a specific point on the LP. The Analogmagik test LP has strategically placed the anti-skating track at a specific location on the test LP, where we believe will result in a proper amount of anti-skating setting. Anti-skating will affect crosstalk measurements, which means it will affect the azimuth. If you are unable to achieve a proper crosstalk measurement, you may have to go back and forth between these two functions to find the optimal setting. What we want is for the stylus to exert an equal amount of pressure on both sides of the groove walls. This will be indicated by the same amount of distortions being measured on both channels. This is where Analogmagik believes the optimal level of anti-skating should be. Simply play the anti-skating test track on the test LP and use the anti-skating measuring function to determine the distortions between the left and the right channels. Perform the measurement with the different anti-skating settings until you find one which gives you the same distortion levels on both channels. Lastly, the anti-skating measurement may not always give meaningful numbers. This is because 12-inch tone arms with a stylus tracking force of over 2 grams usually requires no anti-skating. In such cases, you may not be able to find meaningful numbers. Thank you for watching this video, and make sure to watch our next tutorial where we talk about setting loading and gain on your phono stage. Hi, I'm Lauren from Analogmagik. Today we're going to talk about how to set proper loading and gain on your phono stage. Let's begin with loading. Most phono preamps for MC cartridges will allow users to choose between different loading choices to match with your MC cartridge's internal impedance. Having a proper resistive loading is very important because it has a direct effect on the frequency response of a recorded signal. In other words, if you choose the wrong settings, it would be like artificially pushing the bars up or down on an equalizer randomly. Typically, the manufacturer will recommend setting the loading to approximately 10 times the internal impedance of the cartridge. For instance, if your cartridge has an internal impedance of 10 ohm, then you would set it to loading on the phono stage to 100 ohm. However, this is only an approximation of the actual loading that's required. Without the proper tools for the job, we're often told to simply go with your ear. If accurate analog playback is what we're after, then going with your ears is hardly an accurate method. This is where the scientific methods of the Analogmagik software comes in. Simply play the test LP and use the software to measure the frequency response of the test signal while using different loading choices. The software will find the optimal loading for you by choosing the one which gives you the flattest frequency response curve. The results will be displayed by a number. All you have to do is choose the loading which gives you the smallest number. With Analogmagik, you will no longer have to rely on guesstimates for the job. Now let's talk about setting the gain level on your phono stage. Typically, MC phono stages usually have a gain level between 60 decibels and 80 decibels. In phono stages where this gain is variable, it is often confusing for users to determine the proper gain level. Should you set it to 64 decibels or 74 decibels? Again, we're often told by manufacturers to choose a level which is best suited for your ears. But with the Analogmagik software, it will determine you a gain level which will produce the lowest signal-to-noise ratio. Simply play the gain test track and repeat the measurements with different levels of gain settings. The one with the higher signal and noise ratio is the optimal gain setting. Now, if your ears happen to prefer the sound of higher or lower gain setting, there's nothing wrong with that. At the least, Analogmagik would have determined for you the setting which will produce the best signal-to-noise ratio. Thanks for watching, and stay tuned for the next video where we'll talk about how to measure vibrations and resonances. If you've invested a lot in your turntable, tone arm, and cartridge, you definitely want to make the most out of it. In these tutorials, I'm going to show you how to make your turntable sound awesome. Hi again, I'm Lauren from Analogmagik. Welcome to another episode of Analogmagik's instructional videos on turntable setup. Today we're going to talk about vibrations and resonances and how to measure them. Let's begin with vibrations. The turntable is a device which is very sensitive to vibrations. The cartridge is essentially a small device which converts mechanical energy into electrical energy as the stylus moves along the LP grooves. The only vibration you want to pick up are those that are recorded on the LP grooves. Any vibrations which are being picked up aside from the signals recorded in the LP grooves are just noises. Therefore, it is important to reduce vibrations to a minimal. Vibration comes in many forms. If someone happens to be walking around the room, then your cartridge may pick up the sound of foot stomping. And there are other vibrations generated by the motor, or friction on the turntable bearing, or sometimes even airborne vibrations from the sound of the speakers. There are many ways to measure vibrations, but one of the most effective ways to measure vibrations is to use the software's vibration measurement tool. This measurement function is similar to the VTA function, but is performed with a different set of test signals. The VTA test signals are optimized for determining the stylus raking angle, where the vibration test signals are designed to detect distortions at a frequency where rumblings and airborne vibrations tend to occur. Let's explain what this is. The vibration test track is recorded with two low-frequency signals. Because there are no other sounds recorded on the LP except the two test signals, anything else being picked up are in fact noises. Any vibrations being picked up will also show as these unwanted signals. The software has a proprietary algorithm which will compute and express these noises as a percentage. Therefore, the smaller the number, the less vibration your turntable is experiencing. So, how do we make use of this tool? It's easy. You can even perform a test. Simply run the test and knock on the turntable plinth. You will see the vibrations being picked up on the screen. Say you want to make a change to your turntable, such as going from a rim drive to a belt drive, or you may be wondering how tight the spring should be on the suspension turntable. Now you can observe whether the change you made will produce a higher or lower amount of vibrations, or you can even compare the readings between two different turntables to see which is better isolated. The tool makes it easy to quantify vibrations in a meaningful way. Now let's talk about resonances. Every tone arm will interact with a cartridge and produce a resonant frequency. It is generally accepted that this frequency should be between 8 to 12 Hz. Anything outside of this range will degrade playback performance. The next question you may ask is, how do we measure this frequency? Well, our software will make this really easy. Simply play the test track and the resonant frequency will be displayed on the screen for you. If the frequency falls outside of the 8 to 12 Hz range, you may need to make a few changes. You can change the weight of the tone arm, you can try changing the torque on the various connecting screws, or you can change the tightness of the screw on the counterweight. The bottom line is our software will make it easy for you to determine resonant frequency. With this measuring tool, you no longer have to rely on theoretical formula or guesstimates. You'll be able to determine actual resonant frequency simply by looking at your computer screen. Once again, we thank you for watching our videos, and we believe we've showed you the most accurate method of analog setup. So have a wonderful day, and see you soon again. My name is Lauren from Analogmagik. Today we're going to talk about how to use our program to set vertical tracking force, also known as VTF. In the owner's manual of every phono cartridge is a vertical tracking force range in grams. They usually range between 1.8 grams to 2.2 grams, but some cartridges can track as low as 1.4 grams and others as high as 3 grams. Nearly all manufacturers will tell you track within this range, but what they won't tell you is the exact optimal number to use. Usually they'll say, go with your ear, but going with your ear is hardly scientific. Changing the VTF by even 0.1 grams affects the sound dramatically, and there has never been a product on the market that can determine the optimal vertical tracking force. But with Analogmagik, that's all about to change. We discovered that changing the VTF will affect the total harmonic distortion between high and low frequencies differently. Using a high frequency test tone as well as a low frequency test tone, Analogmagik will analyze the total harmonic distortion for you. In cases where a correlation can be observed, we believe that the optimal tracking force is one which yields the lowest set of total harmonic distortion for both the high and the low frequency test tone. Simply repeat the test with a different tracking force and find the lowest possible set of numbers. We would like you to emphasize that the VTF function is a highly sensitive measurement, and the results are limited by the quality of your cartridge and equipment. Thank you for watching this video on VTF. Stay tuned and see you soon!